It's that time of week again, Sunday, 6 p.m. Pacific. For those of you who are new, this is a Steve's Place. And if you want to find our website, just click on the little square there uh, below the logo there, and that will take you to our website, testdetect.info. And um, and I'd like to announce next year's conference is going to be August 12th to 16th is what we're planning on at this time. We have a request for quotes out to all the local hotels in Albuquerque. It's going to be in Albuquerque. And so we have the request for bids out. This last week, I sent out a call for papers. If anyone's interested, contact me at steve@testdetect.info. It's down below my face there, and we'll get you an email to tell you a little bit about what we expect. Okay. Like I said, it's going to be August 12th to the 16th in 2026. Hopefully it'll be a great year for everybody. And for those who were able to get to the conference this year, okay, if you go click the brown logo on our homepage, it'll take you to where the this year's video on demand is, and it'll bring you to a page similar to this. And here's where you can order the video on demands. You can order T-shirts, and if you'd like to donate, just give us a donation, a few bucks or something. It goes directly to us, and it helps us. It helps us with our costs and these things. A conference, runs about I don't know. I would say about 50,000, and that's on the low side. The hotel alone running about 30, but you got all this advertising, all these other expenses, and so all the money that we make off of our DVD sales and our T-shirt sales and even the donations, that all goes to keeping our conference going. So I encourage everyone, if you get a chance, help us out, by giving like at Christmas, you can give the gift of knowledge, and we'll have DVDs for sale. If you go to our website, you can find our DVDs for sale there and that. But most important of all, right now, we have a YouTube channel, and on it we have all the extraordinary technology conferences from 2024, actually 2023 through 2004. The exotic research conferences I used to do back in the late 90s, and the Global Sciences Conference, which Dean Stoner put together out of Denver for about, from 87 to 2002. A lot of good material, and we'll soon be having some conference on free energies coming up soon too. And if I can get this move going on, I'm trying to. I have about another couple hundred VHS tapes I need to convert to DVDs. So that's where I'm at right now. I encourage everyone, to become a member. At the very least, go to our webpage and you'll see like this little yellow box there. And that box, there you go. That box will have a Tesla Tech channel. You can click on that. It'll take you to our channel. And you can subscribe there. It's free to be a subscriber. And click on the bell, which will notify you. And every time you watch a video or something of ours, go ahead and if you're on YouTube, give us the old thumbs up. That helps us with these computer algorithms, and lets other people find us, and maybe even become members later on. We also have a conference directory. You click on that, and that takes you to my conference directory. I have all these conferences, and I have all these speakers set up by conference. Okay, and then I have a speaker directory, and if you know the speaker, I got to work on some more here for the next couple weeks. But if you know the speaker, I click on it, and it'll bring up all of the DVDs of that speaker that's on our channel. So it's a great tool there. And of course, you can click on it, takes you directly to Steve's Place Live every week. Okay. And so that's a little bit about what we have there. To become to join, uh, okay, you get an exclusive membership, an extraordinary bargain. You know, we have these, like if you look on the people on there, if you see like these little green things, and sometimes I read that, it tells you how long these people have been members. You know, of the channel, and they're actually members. You know, paying members, and they help support us. You know, by being paid members. And the join is like $9.99 a month. I know this is a real rough time for people, but $9.99 is a great deal, especially as I get more and more of these videos up there. Uh, it's a bargain. I mean, you could buy DVDs, you know, like for $30 a pop or $20 a pop, depending on how old it is, and or just watch it online. Uh, if you can get YouTube, you can get to our channel. You know, it's a great deal. I mean, and it's like I say, it's global. It's everywhere. I don't think they even can see us down in Antarctica. You know, so it's a great deal. Anyway, I think that about covers it. You know, and I'll be looking forward to seeing y'all at our conference next year. As soon as I get a registration going, we'll have a great deal for pre-registrations, early pre-registrations. You know, I know times are rough. That's to come. I strive to get a good deal on the hotel, you know, and every night I try to have something for people to eat, you know, so you get a chance to eat and refresh yourself, and at the same time get to meet these speakers face to face, you know, and have a chance to actually talk to a real person. You know, that's what's wrong with this world today. You know, uh, these days everything is done by AI or by computer, or it's on the internet, and you don't really have a good chance at talking to people, you know, and breaking bread. You know, it's it's something that went out, I think, with the COVID. You know, it was on a downward spiral then, but now it's totally gone. Okay, now enough of that. Now let me introduce two guys here. Let me introduce Joe Lowen and uh, Nathan Bunten, and they're going to introduce us to this thing called RAVE, which is a resonant arc vortex. Uh, it's their research into self-organizing plasma. So, Joe and Nathan, can you hear me?
Yeah, we can hear you.
So, why don't you tell us about yourselves? Why don't you go first, Joe, and then we'll go with Nathan. Just about a minute, 30-second thing.
Yeah, sure. So I'm Joe. I do a show with Nathan on his channel, Old Man Builds, where we are mostly focused on different alternative energies, solutions, research, physics, and sort of tying all of the mysteries of the universe together. And I think that we've come really far in doing that in the year plus that we've been working together. I'm sort of a bit of a polymath as far as like my general self is concerned. So I don't have any one particular focus. I just try to learn as much as I can from all these different areas and then bringing it into play for whatever the focus is. And the focus is self-organizing plasma. That's what we're doing. So here I am.
And you, Nathan?
Yeah, my name is Nathan, and I focus on Tesla coils mostly. Build them for other people. I sell them on my channel, and I try to get the most out of them. Try to follow Tesla's work and try to get things done wirelessly and bring wireless power and how to convert it and convert it back. We also work on different types of coils with geometry based. So if you look at a U-tron shape, we build those type of coils. Also round Tesla coils, things that you normally wouldn't see. We design exotic things to do that in. We also look into the free energy devices, how they're built. We go over the frequencies, and we also go over how the circuits are built so that everybody understands how they work. And then on this one we're looking at today is a resonant arc frequency, which is basically fusion that we're going to be able to produce out of it, hopefully, is our goal. But it also has to do with resonance and how we amplify the resonance in order to build this out. So that's where the Tesla coil stuff comes into it. We're hoping that we can add another dimension to what they already do.
Okay, well, let's bring the presentation up and I'll just turn you loose.
Okay. So we have the RAV, or the Resonant Arc Vortex. It's brought to you by Sean Calderon, Joe Lewitt, and then Nathan Bunten. So what we're looking to achieve is a new way to create fusion and self-organizing plasma, discovering transmutation through ionized gas state. A resonant arc vortex, or RAV for short, is a pulsed high voltage reaction between an anode and cathode that produces a coherent spheres of plasma separated by sheaths.
So what separates the RAV formation from more conventional methods of plasma production is a separation of differentials in the initial configuration. This separation is maintained by the use of a ceramic membrane, which exploits the ceramic's natural insulative properties, porosity, and absorbency. This allows for the focused energy from the anode to pull and collect the electrons from the negative potential bias in a controlled, isolated manner within the material. This promotes an equilibrium state to separately form between the negative electrons made available by the cathodic electrolysis of the water and the positive ions generated by the anodic arc. This is demonstrated in the video as the pink and purple negative plasma is seen being drawn out of the clay by the positive arcs and accumulating on the surface in zones separate of the arcs leading up to the RAV's formation.
The sphere itself is self-organizing into stratified plasma with the temperature differentials and resonance frequencies. RAVs are typically confined by their own magnetic field. Ampere's law links current density to J to the magnetic field B. The moving charges in the plasma create magnetic fields that in turn help confine the charges, a self-sustaining loop.
The RAV displays remarkable thermal containment, as shown in the thermal imaging, providing that the high temperatures required to sustain the plasma is contained within the sphere and disproportionately transferring heat to its host environment. The heat signature is tight with limited internal temperature diffusion, which is displayed by the infrared as a non-gradient concentric banding, implying sharp temperature differentials nested within the sphere.
RAV temperatures. RAV temperature when running is 5,000 degrees Fahrenheit to 50,000 degrees Fahrenheit. Temperature per zone when the experiment is shut off. The internal temperature would be 250 degrees Fahrenheit in the innermost sphere. The next level out would be 190 degrees Fahrenheit. The next level from that would be 130 degrees Fahrenheit. And then the outer layer is 70 degrees Fahrenheit. The separation between each of them when running is the sheath.
So the nesting layers inside the RAV's inner geometry is further supported by multiple repeatable observations of known anomalies and defects. The phenomena observed in this video have been identified as a kink defect, a helical plasma filament ejected from the core of the RAV. The plasma kink is formed as it is twisted within the innermost the innermost layers of the sphere due to asymmetric torsion between the nested strata compression zones. In this instance, the asymmetry is caused by the observable RAV satellite in the video, which is in a position locked with the RAV itself. The satellite is cause of a tidal pull upon the outer sheath of the RAV in a fixed location, causing asymmetry to the internal geometry and thinning of the external sheath opposite its position. This gives mechanism to both the formation of the kink as well as cause for the location from which the kink is ejected and, oddly enough, returned.
Plasma is a quasi-neutral gas of ions and electrons. It supports collective behavior, meaning the particles interact through long-range electromagnetic forces. RAV outer plasma layers and frequencies. The top and bottom run at 96.1 kilohertz. The inner layer from that run at 100 kilohertz. And then the center layer runs at 104 kilohertz. RAV often reflects into states of minimum energy while conserving magnetic helicity, with A as a vector potential. This is related to Tyler relaxation, where the plasma settles into force field condition.
Photon HARP testing again indicated that RAV's surface contains multiple frequencies banded at the axial, pole, meridian, and equator of the sphere, and they are in resonance. And this is an indication of the rate of rotation. In addition, the light emission pulse that is observed at the point of maximum expanse appears to be proportionally related to the frequency measured at the equator, which has been measured to consistently time slightly faster than 1 pulse per second. This pulse rate was calculated via video frame analysis at 30 frames per second, and although the accuracy at 30 frames per second lacks the accuracy to directly tie it to 104 kilohertz, the timing consistently showed 1 to 2 frames less than 1 second intervals, allowing for us to draw the relationship.
To create the RAV, you need a high voltage AC flyback with frequency modulation, a porous surface like clay pottery without the glaze coat. This is the power source that's used right here. It's an AC power source. You can see in there are 4 AC flybacks, and there's a 555 timer in there that regulates the frequency itself. The anode should be made of stainless steel, and the cathode wire attached to the stainless steel plate to the lip of it. 4 drops of water placed around the clay or under it, while a wet cotton swab dabbed onto the top of the clay where the anode is directed, 10 millimeters from the surface. The anode should be 90 degrees to the surface of the clay.
Now, as shown by Nathan a moment ago, a high voltage source is required in order to reach the current levels required for the plasma to form and to allow for the anode and cathode relationship to be established. Equally as critical is the general attributes of the chosen membrane samples. As previously noted, clay and ceramic is a reliable substrate for RAV formation. Flat terracotta blanks are used as a benchmark for testing. It is hypothesized that a purpose-built multi-layered ceramic material, each layer specifically tailored to maximize the intermediate reaction, would optimize and control both RAV formation and function. The use of the stainless steel bowl promotes formation and precipitation of hydrogen. And once formed, the RAV displays unique characteristics that can both be observed and measured. Now, backtracking a little bit to the oscilloscope video, as we observed in the oscilloscope video, the arc from the plasma initiates in a variable form of incoherence. As the relationship between the anode and cathode is established through a channel formed within the membrane, the wave forms stabilize in resonance as seen on the oscilloscope reading. The creation of an exchange portal in the membrane also allows and marks the RAV's formation, which directly corresponds with the system falling into resonance. In addition, there is a direct correlation between the parallel but opposite current vectoring of the anode and cathode. Once the negative electron path to the anode is made and the positive ions penetrate to the material to the cathode, the two opposite vectors achieve asymmetric equilibrium. The vector paths broaden due to the polarity bias, creating a third magnetic vector. This is directly the cause of the plasma's compression, rotation, and the RAVs formation.
The goal is to produce a resonant frequency between the anode and cathode around 96 kilohertz. When the anode first discharges, it reduces the frequency to 50 kilohertz until it locks onto a spot in the clay where the water under the clay can touch the water on top of the clay and create a temporary cathode connection. This is one of the samples that we pulled out of here, where you can start to see it's getting shiny on there, where the new cathode is formed right here.
Right. And as previously explained, the formation of the channel is critical to RAV formation. All the testing has confirmed that once the channel is established within the membrane, RAV can be formed nearly instantly once the minimum power level is achieved. The channel is formed as positive ions consisting of oxygen, nitrogen, and metallic elements from the anode, being iron, chromium, and nickel, are carried by the arc and forced to permeate the ceramic structure. The ions are further drawn into the ceramic by an electrolytic attraction until the ion deposition penetrates the full thickness of the membrane to the cathodic side. It's hypothesized that the deposition forming in the channel may be a gradient of metallic oxides nearest the anode and metallic hydroxides nearest the cathode. There is also a potential for novel hydrolytic compounds and reactions to be developing. Further testing is going to be required to confirm the true composition of the channel. There are strong indications that the channel formed maintains a negative charge bias and potential after formation, providing cause for the ability of the quick startup and the ability to start up without a cathode. It is worth noting that removing the initial water and the cathode and running the RAV on the channel removes most of the hydrogen potential, which may impact the layering and free electron availability.
As this plasma starts to form on the clay, has what looks like a carbon or deposited on the surface of the cavernous structure. The structure will act as a cathode from this point forward, and the original cathode can be removed and used as a second anode.
Very cool.
Yeah, this right here is two anodes working. There's no cathode in the situation. They're interconnected through the AC flyback. The one on the left goes a little bit less bright. The one on the right is taking the energy from the one on the left and creating a much bigger RAV in the process. As you can see here, we have the same thing going on. You see a very small RAV on the left and a very big RAV on the right, where more energy is bursting out of it. Right here, they look to be completely equal as they're created on the same piece of clay, but it will adjust back and forth to each other. MHD equilibrium. The plasma structure is created by connecting the new cathode of carbon with the rotation of the high voltage on the anode that spins in one direction. The main equilibrium condition between the magnetic pressure and the plasma pressure, where P is the plasma pressure. This is, in essence, a
Magneto. Yep.
Sorry. Magnetohydrodynamics, sorry, MHD, which describes plasma as conducting fluid.
Yep. And as Nathan also pointed out, the equilibrium state of compression and rotation is an MHD effect. As with all MHD processes, RAV has both unique novel qualities as well as high potential for practical use in both conventional and emerging applications. So now the sheaths and zoning depicted in this video allows for the separation of differentials in an equilibrium. This allows for RAV to maintain its stability. The sheaths are the boundaries where one zone ends and the other begins. The sheaths are formed and maintained by torsion and compression caused by the differentials of each layer. These differences between layers, though coherent, cause stress and a pressure increase of the boundary plasma, increasing the sheath density of both layers in that zone. Since both layers are in coherence, there's no energy loss to either layer as the zones interact laminarly. The implications of a low energy self-contained plasma in resonant cavitation are resounding. There have been countless novel observations in our experimentation to date, and we are currently proceeding forward with our research, including exotic applications.
Joe, would you like to explain this part?
Sure. As we described before, there is a circumstance where the anode and the cathode are actually feeding directly parallel to one another in opposite vectors. Once the cathode is able to feed electrons to the anode side, and then the ions are able to penetrate the permeable layer of the membrane to the cathode side, those vectors come up and cross, okay, and those two crossing vectors create a third vector, which is a magnetic component. These multi-directional vectors create an axial spin on the RAV. So it not only allows for the containment and for it to ball up and stay consolidated, but it also adds the rotational element.
Each layer of plasma will have a sheath. A plasma sheath is a thin boundary layer that forms between the plasma and a solid surface. The temperature builds out from the core at high temperature and lowers the temperature from each sphere of plasma until it reaches the outside layer of plasma. The testing includes a HARP device connected to the oscilloscope used to measure the speed and the resonant frequency of each layer of plasma. This is a schematic of the HARP device and exactly how it's being used.
And right here is just a basic configuration of the RAV, where the anode is pointed directly down on the ceramic surface. The ceramic surface is wet, which really only has to be done prior to the channel formation. And then you could see it run. And then you could see when the RAV forms because it falls into resonance right on the scope.
A thermometer is used to determine the temperature of each layer when the RAV is turned off. The residual heat can be measured on the clay to determine the layer sizes. Voltage, amperage, and frequency of the DC pulse wave going into the AC flyback can be monitored by a voltage and amperage meter. An oscilloscope. For safety, a Geiger counter is set up 1 foot away from the experiment where the operator has eye protection. The goal of the RAV is to study the plasma resonance govern a self-structuring plasma field. If an outside resonance frequency can be applied to the resonant frequency in the plasma to increase the amplitude of the plasma to the point of full potential for energy production. The RAV has a proven form in 2 different frequency zones, and we hope to find more zones it can be formed in. We will also explore the the environmental conditions that the RAV can form in and exist in polar prolonged periods of time. While there were many camera effects each time we experimented, we did not use those to come to any conclusions in this presentation. We are, however, taking a closer look at them to see if there is something of merit in the future. This right here is a picture of a RAV that's built out from my side that I built. And as you can see, we have different colorizations that are going on here. There's obviously the camera effect that you see in the purple. And then you have light that's built out, which is actually dark.
So this is an experiment where we're using an established channel to the cathode beneath the piece of quartz, and we're trying to entice the plasma to create an ion channel through the quartz itself, allowing for the plasma to become distributed through the quartz. This particular test was successful. However, due to the configuration being out of resonance with the quartz itself, it had the result of catastrophic malfunction of the quartz, which is super awesome to watch, but not what we desire the ultimate outcome to be. But that was a really, really awesome test that has some really amazing implications because we were able to inject the plasma information into the quartz.
As you can see here, everything is lit up inside the quartz to give a brighter structure. Where here you can see it's going around it. And obviously here, there was too much pressure and it exploded very beautifully.
There's also some unusual phenomena that we could talk about another time in that. But yeah, incredible test.
One of the things that keeps showing up is anything that has a surface on it that's shiny will be blocked out on the top of it. And we haven't come up with the entire effect to it, though we have seen that the actual light that comes off of it is dark.
Yeah, and that's not any kind of camera effect. It actually looks this way when observing it as well.
This is the RAV that's built out for me, and you can see once it forms, this one is not in the correct frequency, so light escapes it everywhere. The ones you saw previous to this were in perfect harmony, so the light stayed within them. As you can see, they put off a beautiful effect. They'll blind you if you look at them without any kind of eye protection in them. These things are extremely powerful as they build out. And this one right here was one of the brightest ones that I had. It absolutely put out a tremendous amount of energy.
Now, it is worth noting that the way that it's configured has a lot to do with the observations that are made of the RAV itself. And in Sean's configuration, which is the initial benchmark configuration, there's so much compression within it that very little escapes from it. In Nathan's case, he has a little bit more escaping, which has actually led us to be able to realize separate phenomena such as like transaxial laser, coming out of it in coherent light, and it'll band out, give prismatic effects to the, to all the, light coming out. And on top of that, this again is not a lens effect. The light actually distributes in this fashion in the environment. and it generally asymmetrically lights the environment for how bright the RAV actually is. Like, there's no words to tell you how bright this actually is. So
Here's another picture of two RAVs forming. And we had an anomaly show up when we were doing testing on Sean's side. And you could see the plasma that comes out of there. Instead of balling up and forming the RAV, it actually ran out and looked like a liquid. Here's the video of it right here. As you can see, we're blowing plasma out everywhere, and then it'll start to form, and then you see it right there.
yeah, that's strange.
In doing research for this video, by the way, they say when this type of state happens, you have to supercool it and to see if you can actually get a solid form out of it. Yet we're not anywhere close to doing that yet. But we wanted to show the plasma how it looks basically like a liquid form of energy.
Yeah, it definitely is like a viscous liquid in the way that it works, in the way that it moves and travels and looks. The funny thing about it though is that it you could see also like the motion that the current that generates it, and it's just so asymmetric with the perceived viscosity of it due to the high density levels that it becomes like nothing you've ever seen before.
Okay, Joe, that's the full presentation.
Yep. So next steps and what we're currently working on. I think that the initial idea here is just to show practical use, right? So we know that it's in a contained state, that it has it's in resonance, and it has this pulsing element to it. And I think that the next step for us and what we're currently kind of getting our minds together and working on is just being able to extract that resonant value from it to show that there's actually something useful that could be pulled off of it. And that way, it gives application to it right off the bat, regardless of what those figures look like. And then from there, we could work it out as far as maybe making it bigger and a little bit more powerful, or bring more than one into the equation and seeing what the result is. But the testing is quite positive so far, and I think that increasing the hydrogen levels and just making sure that the cathode feed is regulated properly to give it exactly what it needs is going to show probably the biggest gains, because there's a lot going on inside this as far as electrons and atoms bashing into each other, creating lots of heat. And there's a lot of different types of plasma in play. So there's high potential for transmutation and things of that nature as well. And these aren't things that we're claiming at this time, but it seems that the potential is there.
Also, I just want to let everybody know the resonant part of this, we're working on a system to be able to amplify the resonance inside of it. Some preliminary testing so far has shown that when you use a capacitor bank on the driving circuit, that we're able to amplify the size of the actual RAV itself by a little bit. So we're hopeful that that will actually take place a little bit more in the future so that we can get a higher volume of energy that pulls out of this thing. We're also looking at chamber testing. Now, one of the unique features of the RAV is that it's self-forming inside of the air that we live in now. So we didn't want to take that away, but we also understand that we got to be able to put a chamber around it so that we don't have anything coming out of it that might be radiation or any form of it. So in those two considerations, we're going to have to find a way to make a containment unit for it and a way to look at it that doesn't blind you.
So how would people contact you if they want to know more?
Basically, you can contact me on my email or anytime on my page on any one of the videos, and I'll get back to you right away. I'll leave my email right now in the chat.
Okay. And then, and you're the same way, Joe, or you just,
Yeah, absolutely. If you reach out to Nathan, you want to get in touch with me, just let him know. He'll link you up, and I'm more than available. And if anybody out there also thinks that they have what to add into this conversation, if they ever want to set up doing a live Q&A or anything on Nathan's channel, that's something that we could accommodate as well. So feel free to reach out to us.
okay. And there's the old man Nathan Bunten at gmail.com.
I love it. Hey, I earned every one of these gray hairs, okay? I got 5 kids.
Yeah, well, I tend to try to keep mine short, So,
I love it.
I just have Steve at testatech.info.
Nice.
So how long you been working on this?
This has been around 3 months so far. So we're still kind of in the preliminary stages, but we have 3 people building their own setups. And at this point, I'm one device away from verifying all of Sean's setup. And we'll be using the same clay and everything. So we're in the basically the beginning of it. I have a feeling in the next few months we're going to get things together where we start measuring the anodes coming out. And if there's a second anode, we have to measure that each time that we test. There'll be protocols put in place just to make sure that we don't have any destruction of any of the anodes. There'll also be in there measured clay in the same clay so that we can respectfully get the same thing. And we'll also be putting out some of the testing material that we used over to an analysis center to be able to see exactly what we're building in them. So we're still relatively in the beginning phases of this, but the next phase is going to be more scientific, more structured, and hopefully give us a really good sight of what we're looking at.
Well, I noticed that you had you keep a Geiger counter, as well as safety glasses there. And I guess we should probably emphasize to people here that anytime you're dealing with sparks, you have
Radiation?
high energy radiation coming out of it, and you should always be aware of that, a lot of guys, they build these Tesla coils and that, they don't, well, when I started doing, I was totally unaware of that myself, about the spark gap. That's where most of the radiation really tends to come from, right there. And I don't know, did you ever know Bill Weissack by any chance?
No, I don't.
He built some huge Tesla coils, and at one of our conferences, he had a 2.5-story Tesla coil with an extra coil.
Beautiful.
It would throw about 60 to 70 foot arcs out, and we had a guy, come out from California, a fireman, and we had a crane that we were going to lift them into the sparks, so they be arcing around the cage there, show how safe this really is now.
Oh, yeah. Did they get them up there?
Well, what happened is, we even had to dig across. We were in a rodeo stadium, and we had to dig a trench across the road and tap into the city main power to get enough power for his coil. Okay, and they let us do that because a lot of our members were actually employees of the power company.
Okay.
It didn't cost us nothing, luckily. But on the day of the show, just as they're getting ready to go, a rain cloud come out of nowhere. Just one rain cloud and just settled right on top of the stadium. Just poured out so much rain that there was a water gushing out knee high out of that stadium, and everything sunk in the mud, so we couldn't get through to do that demonstration.
Oh, wow.
Probably
a good thing for everybody.
Well, that was a bummer.
Yeah, oh, I know.
I mean, and it cost a lot of, it was an expensive rainstorm there for us, because we had to dig it. It took us a couple of days to dig everything out of the mud, because of a rodeo stadium. And I did see him get it running up and running again when I went out to visit him out in Monrovia there at the airport. There's an airport near there that he had all set up. And when he turned it on, next thing you know, there's all these cops coming out of nowhere. And the lady across the field from where the radio station was that we were using to do this at, she called 911 to tell them the radio station was blowing up.
Oh,
But yeah, Tesla coils can be fun, you know. And I think everyone should be trying to do, you know, it used to be everyone I used to know built Tesla coils, you know, but it seems like it's a dying art these days, you know. Have you run
we hope to change that, especially when we come out with geometry coils and just beautifully built Tesla coils. I'm hoping to change that.
So on your capacitors, what kind of capacitors do you use for your coils in there, or do you use it?
Usually we use high frequency capacitors, the same thing you find in the spark gap Tesla coils. You can use the regular capacitors that are slower, that are not high frequency. It just limits the arc you're able to get. It creates too much heat in the system and draws it down. But high frequency capacitor is what we generally use in there. And we built a capacitor bank where all you have to do is every capacitor set up and have a switch right under it. So as you flip each switch, it brings you into a different level of resonance. So you'll see your oscilloscope reading like this, and then you'll hit the switch and it'll jump. You'll hit another switch and it'll jump. So you're able to tune right on the spot as it's running. So you can get the highest frequency possible, the highest amplitude you possibly can out of this thing, and then run it. And we do that in DC. Once you have it set in DC, you can switch over to AC and just start cranking that variac. And I've had 13-inch lightning bolts shooting out of the top of this thing. So, yeah, we do little quick tricks to help people. And then we have a self-resonating circuit. So, like the Slayer exciter always finds the highest amplitude possible in your coil when you set it up. And it's immediate. As soon as you turn it on, it finds it, and it has the best radius possible. So we use one as the ZVS circuit and then the PNP circuit. We also use an NPN circuit, though it's not as powerful as the PNP. There's a little less heat in the PNP circuit that we use. But both Slayer exciters, and then we use the ZVS circuit, which with the coil that we build, never a problem. We're never more than a couple clicks away from the cap bank to actually run this thing.
So
I run mine without any of that straight off of PNP.
Yeah.
And I do, and it's worth noting that the principles that we've described in today's presentation is a game of differentials, okay, and that's all it is. So when you separate and bring your differentials together, intermedium, right? This is actually the reaction that you get, and it doesn't matter what it is, hot and cold or high and low pressure or whatever it is. When you bring these differentials together in this manner, you actually end up with your differentials separate and contained in a ball. This is how it goes, and this is how weather works too.
So you're doing all this work though in just a regular atmosphere, right?
Yes.
Yep, that's what makes it special, because I mean, this is done before. I mean, self-contained plasma balls, it's done before. It's done in a vacuum chamber under controlled conditions, under a magnetic, an external magnetic component to keep it under compression. That's done, but this doesn't take any of that.
So what it actually does is it allows us to build this thing out without all the extra energy of the compression to put it in. So all that magnetic field out there, we don't necessarily need all this. It's already compressed in itself. All we need to do is bring up the amplitude of the frequency in order to increase the size to give it more pressure. So it saves a lot of money when you go to build out these things. So now the power required to run it is so much less. We're hoping that the amount that we get in return would actually be close to what they get. That means that we're going to be even or above at some point.
Yep, and it seems that's the direction it's headed.
Well, it makes me wonder, like Tesla went to Colorado Springs, For one, so you could work in rarefied air. And so I wonder what would happen to your device, if you took it up. Well, if you come to Albuquerque, I know you're a mile high up there. I don't know if you're aware of that, but so your pressure is going to be a lot different. I wonder.
Well, I've been in Denver. I know the difference.
Okay. Yeah. So
Yeah, it'd be interesting to find out. If I could take a trip up to one of those zones, I absolutely will bring a Tesla coil and the RAV and try them out. Not a problem there.
No.
Yeah, I mean, for what it's worth, I'm at a little over 2,000 feet altitude, and it gave me no problem whatsoever forming stuff.
Yeah, but
I mean, that's not a mile, but I don't think it takes.
That's different. They're entirely.
Yeah.
I don't even think you should breathe the same chemicals we do.
Probably not.
Yeah. So that's New York. I had a friend. He actually owns a castle there, the Gold Castle in Leon's Falls.
Okay.
Yeah, he owns a castle there. So if you want, I'll hook you up one day.
That'd be cool. There's a lot of castles in New York. That's something strange about it. I've driven around. I'm like, oh, look at that castle. more than once. So.
Yeah. Well, he says this place is so big, he got really super cheap. But he had his whole family there. About 30 or 40 people, and the place still felt empty. Yeah. Unbelievable.
Cool.
He used to volunteer for me all the time, and come over to our museum just about every night, and help us out do stuff, So anyway, is there any questions that anybody has out there? Anyway, if not, I want to remind everyone, about our conference coming up in August. Oh yeah, and I'm also extending the special for the $100 off for the set of DVDs for another 2 weeks. Maybe even more. Maybe take it out to the 15th. But yeah, it's been this material is hard to find. You just can't walk out anywhere. Even in these colleges, for some reason they don't seem to really pursue hands-on stuff as much anymore. And I find that a shame because, like, when I went to college, I was in AA, and I was doing communication theory, and part of that was basic basic radio circuits. We built spread spectrum systems and everything, and tried to jam it up. It was all hands-on. And for me, the only way you get to know this stuff is if you're actually doing it. Like
absolutely.
You guys, So anyway.
Yeah, it took a long time to learn circuitry when you didn't know any, and you try to start this stuff up. I had done it when I was a kid, and then coming back to it when I retired was so much different, and it was so much easier, beyond easy now, but it was a lot easier to learn it when you're older because you actually want to pay attention at this point because you have to get it right. Because I'm going to tell you, I have a thing on my channel, I fry everything to find out, which basically means I run it at max level, because the first thing anybody does when they get anything is run it at max level because that's what they said it would do. So I have to make sure that I do it for long periods of time, and I've fried everything under the sun to find out just where the level is comfortable, and where it is, I know if you went over. So yeah, I test everything that I build, by the way, just so everybody knows. That's why they call me the old man builds, because I literally will find something that everybody agrees on they like. They say, I want a geometry coil. Maybe it's a U-tron shape. Sean's built sphere shapes, also pyramid shapes, everything that's under the sun. And while it's not conventional Tesla coils, the way they run is exactly like it. So we could be taking like an AC flyback winding and put a number 1 coil on it and run it as a Tesla coil. And the beautiful amount of sparks that comes out of this thing, if you run it in the AC, it makes a beautiful purple plasma that does not like to attack things. It's so strange. When you get into the geometry aspect to it, normally there are lightning bolts that come out and everybody sees a beautiful RF out splits apart. Well, these don't do that necessarily. There's still RF in them, but the amount of purple is so much higher. And then when you go to put your hand next to it, it tries to avoid your hand at all costs. Where a normal Tesla coil would zap you as soon as you put your hand near it. It's interesting in the way that these things work. Some of the experiments you mentioned, Colorado, I did experiments on my channel with how we did the Colorado experiment. We put a rod down the center of the Tesla coil, and we're able to get it into the water table. Once I get it into the water table, I can light up light bulbs, 4 feet away. I could run the wire into mud, and it'll light it up 4 feet away. It's a different understanding because you're dealing with the impulse of the center of the coil instead of the pulse field of the outside that everybody writes papers about and talks about. I use a completely different structure. It's like Tesla did, right down the center of it. He did the same thing in Wardenclyffe, got it right down to the water table, and the energy travels through the water table. So when he says 6 miles out, he lit up a light bulb, which was just a gas light bulb that he started the gas, and he put it into the ground. I created the exact same effect in my backyard.
Wow.
So another fun thing that you just said, right, about that plasma kind of chasing away from you, right,
Mhm.
and chasing away from your capacitance. Now, because of how I configured my setup, making the RAV did the same thing.
Really?
So if I was on one side, it'd try to go to the other side. As if you just try to move, and then it goes to the. It's like, can you stop that, man? Do you mind? Yeah, but it's very interesting stuff. They do call them plasma entities. That's how they're referred to, and they certainly have behaviors. And I think that that's a really fascinating aspect of what we're doing, and what the Tesla coil also brings into the equation. And Nathan's talking about the center energy from the Tesla coil right now. I use that center energy as my cathode in that, because of how it disperses in the water. And that gives it again, game of differentials, positive, negative, hot, cold, inside energy, outside energy, however you want to think about it. It's just the opposite of the breakout side. So you're able to get that similar effect.
I
Yeah.
used a bipolar Tesla coil to make a RAV as well. Because once you set in the center of it, and it has equal sides, each side is equal to the resonance frequency, and then you can put them together and they spark. So you get an anode cathode relationship between the two in a bipolar Tesla coil. And it doesn't matter the geometry you use. I use the U-tron shape, which is basically like this. So it looks like two cones coming into each other, a top cone and a bottom cone. And it's on the side, it looks like a square. Absolutely beautiful coil. Made the most beautiful RAV right away. You just clip the capacitor bank, and here's what you'd see on your oscilloscope. The line would be here, and then you'd hit the cap and then amplify, and the RAV would grow in size. Then I hit it again, the RAV would grow again. And then I hit it again to the maximum, and this RAV was blinding. You couldn't look anywhere near it. You get free LASIK from it, basically, is what you're getting. Yeah.
And it's like Nathan was kind of saying, and like we described before, this, as significant as the RAV is in all of its implications, I think one of the most significant things that's already come out of this is the more or less metamaterial that is formed in that channel. Okay, that is extremely critical to the process. It's really the only way it can form. We know a lot more about it than we talked about in the presentation. That just hasn't been confirmed yet. Like, for instance, I've been able to get the ionization deposits through denser materials that are far less porous, and using alternate anodes. So like copper anode through a semi-porous rock, which is double the density of clay and ceramic, and I'm still able to get the ionic permeation all the way through to the cathode side, with high voltage but very low energy. As far as that's concerned, like it's far less, like my setup is far less energetic than Nathan and Sean's, the way that it's set up. And I was still able to get that channel to form. And that's critical aspect stuff, because this allows the formation one wire energy. So you only have to have one wire to start this plasma ball in a stable effect once that channel is formed.
Okay. Well, with that, I'm going to go ahead and call it a night, if you don't mind. And
Right on.
Absolutely.
I'm going to remind you guys about our conference coming up, and get your abstracts in there, and we'll see where we can go from there. And remind everyone, we'll be here next Sunday at 6 p.m. And thank you all for coming. And
Thanks for having us.
Thank you. Thank you, Steve.
and we'll get together soon. Yeah.
All right.
All right.